Now let us calculate the magnetic field for a coaxial cable by using the Ampere circuit law. You can consider the cross-sectional view of optical fiber where A is nothing but the inner radius of the inner conductor, and B is nothing but a inner radius of the outer conductor, and C is nothing but a outer radius of the outer conductor. Okay, so you can consider the current flowing in the cable, let it be capital I, and the flow of a current in the inner and outer conductor, let it to be opposite in nature. So now you can take the region rho is less than a, and we know that the cross sectional area of this cable can be represented as a pi rho square, and the total current which is flows through the capital I in the area, that is pi a square. So the current which is enclosed by the path is given by the ratio of this pi rho square divided by pi a square into the total current capital I. So pi and pi get cancelled, so we can get rho square divided by a square is equal to capital I, and we can define the h value. H is equal to h pi into a pi, and dl is equal to rho into d pi into a pi. This actually comes from the differential length for a cylindrical coordinate system. Now we can perform a dot product between this h and dl, so rho into h pi into d pi. So this a pi dot a pi may become a 1. So now let us apply the Ampere circuit law. We know that integration of h vector dot dl is equal to the total current enclosed, and you can substitute the representation for h, the representation for a dl, which is evaluated over 0 to 2 pi. Okay, and this will be equal to rho square divided by a square into capital I, and after integrating this with respect to the pi, we can get 2 pi. So this may become 2 pi into rho into h pi, that will be equal to rho square divided by a square into capital I. So h pi is equal to rho divided by 2 pi a square into capital I. Finally we can get h vector is equal to I into rho divided by 2 pi a square into a pi. The unit is ampere per meter. Next, for a region, this rho lies between the A and the B. Now this may be considered to be as a the inner, that is the medium which lies between the inner and the outer conductor. Therefore this case is similar to the infinitely long conductor. So instead of making the derivation, I can directly write the formula for the infinite line carrying a current I. It will create a magnetic field of H is equal to I divided by 2 pi rho into a pi ampere per meter. And for the case of a region which rho lies between B and a C, as I said earlier that the outer conductor, the current flow may be considered to be in negative. So the total current minus I is flowing through the cross sectional of pi into C square minus D square, while the closed path encloses by the cross sectional is pi into rho square minus b square. Now you can make a ratio between this. I dash you can consider as pi into rho square minus b square divided by pi into c square minus d square into the total current, that is minus I. So pi and pi get cancelled, you can take the minus as a common. So the total current I enclosed will be I dash plus I double dash. So we know that I dash can be calculated as minus I. This is nothing but a area, rho square minus b square divided by c square minus b square plus I. You can take the value of I as your common, and you can take a LCM for this. Finally we can get I enclosed is equal to I into c square minus rho square divided by c square minus b square. Again you can go for your Ampere circuit law. We know that the integration of the closed integration of h vector dot dl is equal to I enclosed. So now you can proceed the corresponding value as like the previous one, and you can get h rho 2 pi is equal to I into c square minus rho square divided by c square minus b square. So finally we can get h pi is equal to I divided by 2 pi c square minus rho square divided by c square minus a square. So finally we can get I divided by 2 pi rho into c square minus rho square divided by c square minus a square into a phi. And the region for rho is greater than 0, it encloses the total current of plus I and a minus I. If I am adding those two values, I can get a 0. Again we can get integration of h vector dot dl is equal to 0. So this is the case for the coaxial cable. It can be applied or it can be considered as a 4 region current.